Pretty similar to what we did yesterday. We're finding the equations for lines of best fit. There's a couple different ways you can see these in problems. One way is sometimes they just give it to you as a table. You know, normally if we had a table, you'd find like you could do your slope, you could do your y-intercept from the table, but what you'll see is it's not always going to be changing by the same amount. So from here to here, I'm going up, or I'm going down by 75. There to there, only going down 3. So when it varies like that, that's basically like the order pairs for a scatter plot. They're a little more random, whereas if we had a full-on linear function, it'd be going up or down by the same amount every time. So I just wanted to show you this one as an example because sometimes they're not so tough. So if you look at the answer choices, every one of the answer choices has 1/25. 2 of them have positive 1/25, 2 of them have negative 1/25. All right? But the 1/25 is our kind of slope number. Then similar idea for the y-intercept. 2 of them have plus 75, 2 of them have minus 75, right? So we could do this pretty easily without using Desmos at all. If we look at the left column there, the elevation, that's our x values. What's happening to those numbers? They're going up, all right? Our temperatures, what's happening to our temperatures? They're going down. So if one's going up and one's going down, who remembers what type of association is that? Negative. When they're different, when they're going different directions, that's a negative association. All right? For it to be positive, they have to both be going up or both be going down. But since they are both, or one's going up and one's going down, that makes a negative association. And the association is what determines our slope. So that means we got a negative slope. All right, so we eliminate the 2 with the positive. Now we have to figure out the y-intercept. Y'all, what's the x value for a y-intercept?
Where the line crosses it.
What's the x value for a y-intercept always? If I wrote the ordered pair for a y-intercept, what would my x value always be? 0. Y-intercept, the x value is always 0. It's crossing on the y-axis and the x-axis meet at 0, 0, the origin. So y'all look. Ain't that my y-intercept then? Yeah. Even if that wasn't my y-intercept, as the temperatures are going down, we're starting at a positive number, aren't we? So since we're starting at a positive number, that means it's got to be the positive y-intercept, and we know it can't be that negative one. Make sense? Like I said, didn't really do any math. I knew one was going up, one's going down. That makes it a negative association, so that's the negative slope. And then I started from a positive number on the temperature. That means I have to start from a positive number with my y-intercept. Okay? Now, they don't always work out that way. This one I didn't even give you answer choices. So go ahead and get the equation for this one. Remember yesterday I said you only needed 2 of the points? That's when we already had the line. You need all of them. For these today, you're going to have to put in all of your points. Also, when you enter in numbers on Desmos, do not put the commas in there.
Okay.
So all those 5-digit numbers in the Y column, do not put commas with them. It gives you some sort of error symbol, exclamation point, I think. All right, Corey, what you got? No. Yeah. So we got Y equals. Yo, what's happening to the value of the car? And the years are going up, right? So that means we got a negative. It ends up being negative 2,000x. I didn't leave enough room to do this all in one line. And then we got, what was it, 22,200. Okay? Anybody have any questions on that? So, two of the things we noticed on that, or some of y'all noticed while doing that, can't put commas in when you're working with Desmos. If you put commas in, it's not going to work for you. When you do your Y1 with the squiggle line, we got to use lowercase letters, okay? If you have capital letters in it, it gets kind of messed up. All right, so that's what it's a table. All you have to do is copy the table in, and easy enough, get the equation. All right, so this one, I guess I stretched it a little too far, so it got a little blurry. But no table. So guess what we got to do? We got to make the table. All right, so if I have a table, what I need to do is I need to make ordered pairs for each one of those dots. All right, now what this is doing then, this is making this much more of an estimate because we're not always going to have exact numbers. So I got a point here. I'm going to call that 0, 3. Is that exactly 0, 3? Definitely not. Because you can see this one is a little bit higher, isn't it? I'm still going to call that 3 for my Y value. This time I'll call it 1, 3. We'll call that 2, 5, and it's probably lower than that. 3. We'll give that one 6, saying it's closest to the 6. 4, 7, 5. We'll call that a 7 again. 6 and 9. I'm down to 8. 8 and 10. What's this? 9 and 11. And that'll be, we'll call that 12 and 13. All right, so again, are any of those probably 100% correct? No. Are they probably pretty close? Yeah. So what they're going to do is they're going to give us something close enough to the line of best fit. All right, so that's our one option. That's probably one of the easier options. And as we estimate, we maybe don't have to use like all of the points necessarily, but we should try to include probably at least 5 of them that are pretty close to the middle, okay? The more points you use, the more points or the closer you're going to get to it. All right, did anybody go ahead and put that in and get the equation?
Y equals 1x plus 1. Yeah, so
So what's that about? All right, so we'll put it like about 0.8x plus 3 if we round a little bit, right? All right, so if it's 0.8, that's like you go up 4 over 3 kind of thing, right? Or not, sorry, up 4 over 5, my fault. If we drew a line, you can see my line is going to intersect at about 3, right? That looks like the middle of the data. And if you kind of look slope-wise, and I went up 4, I'd be right here, and I said over 5, hey, that's about right there. So that kind of fits with that estimate. Is one of the answer choices going to match that exactly? Probably not. So you got to do a little bit of rounding and pick the one that's closest. We're looking for the line of best fit. So it kind of becomes like a ELA type thing on like which one fits best. All right, this one has a few less points. So go ahead and give this one a try. Get the estimates for your ordered pairs and kind of see how that goes for you. That's what you got to figure out. You got to figure out what's between some of these numbers or which one should be there. I'll take that. He had 85. He had to do a little rounding on his. Some of y'all might have different. See, Marcos here has 2.32x plus, was that 68.4? So when I did it, Aubrey has 2x plus 73. When I did it, I have 2.25x plus 72.9. when I round. So you kind of want it in that range, right? You should have probably between 2 and 2.5 for your slope, and probably somewhere between like the upper 60s and 80 range, right? When I did this, the ordered pairs I used, you know, our X's are just going to 5, 10, 50. Sometimes you have to guess on both numbers, but having like exact for one of them does kind of help. To me, that looks like that dot is halfway in between. Halfway in between those two is 82.5, so that's what I used. Same idea, next one, halfway in between is 97.5. This one looks pretty 5. Same there. This one might be a little less than halfway, but I just made it halfway. About halfway again. The last one's right there on the 150. All right. Anybody have any questions on that? All right. Everybody see how we got that, right? We made some estimates. Looks like from the ones I saw, all y'all were right pretty close. Now, if we look, I know this one exactly. I know this one exactly. I know this one exactly. Right? Everybody, or it looks like exactly. I guess technically it could be like a 0.1 type situation or something, right? So what we're going to do, oops, I'm erasing too much. You see these 3 points? Oops, that should be 15. That should be a 15 and a 105. The 20 and 120. And then 35 and 150. Go ahead and put just those 3 into your table. Then whoever gets your equation first, raise your hand and let me know what you got. All right, so he said y equals, what do you say, 2.19x plus 73 point what? 84. Yo, isn't that pretty close to what we had by putting all the points in? So as long as you have points that you know are exact and they're pretty close to the middle if you drew a line, or it looks like it's pretty close to linear, which this one's pretty close to linear, isn't it? If they're pretty close, you can use just the exact ones. The more points you use, though, the closer you're going to be to getting it exactly like an answer choice. So if you did that, just those 3, you might be off on the answer choice a little bit. All right? Like I said, this is kind of getting some estimates, right? It's not going to be exact always.